In this video, we're going to be putting all of what we learned in the last couple of videos together, and we're going to be figuring out exactly how many protons, neutrons, and electrons are present in any given isotope or ion. Again, you're going to need your fill-in notes or regular notes to work with, and you're going to need a pencil or pen. You may also want a calculator because we're going to do a little bit of subtraction here. You can get by without it, but if you want one, feel free to take one. And once you have everything you need ready, let's go. So to basically start off with, we'll take our atomic symbol from last time, right? So we have our element symbol, which is X. We have our atomic number, which is Z, our mass number, which is A, and now that we have the ability to work with ions, we're going to have a charge, so I'm just going to put a little C up here for charge. Okay, so here's how we go about figuring this out. The number of protons is equal to the atomic number, which is just equal to Z. Right, so straightforward. You don't even need to be given this number. Just look it up from the periodic table and you're good to go. The number of neutrons is the mass number, right? So that is A minus the atomic number Z, and that will get you neutrons. The number of electrons, so remember, a number of electrons, the charge is the difference between the protons and electrons. So that's going to be our atomic number minus the charge. Right, so this is how you find out the number of each particle in one of these symbols or in any isotope that you're working with. So what I want you to do, and this is going to be the only other slide in this video, is I'm going to give you a couple of examples. I want you to take a couple minutes, try to work them out on your own, and then we'll go over them after you've had a chance to try them yourself. Okay, so here's what we're going to be working with. Two elements, or two isotopes in this case. We have copper and we have chlorine. Pause the video, take a couple minutes to do it on your own, and then once you got your answers, pick the video back up and we'll go over this. Okay, so hopefully you've gotten answers to this. We'll start off with our copper. The number of protons, remember, is the atomic number. So in this case, that's going to be 29. Now it's easiest to do electrons next. If I don't give you anything up here, then we assume the charge is 0, right? It's electrically neutral. So the number of electrons is 29 minus 0, or 29. The number of neutrons is the mass number, in this case 63, minus the atomic number, which is 29, and that gives us 34 neutrons. And then for our chloride ion, number of protons is the atomic number, so that's 17. The number of electrons is our atomic number minus the charge. Right, so we're going to subtract -1, which is the same as adding 1, which gives us 18 electrons. And again, the number of neutrons is equal to the mass number 36 minus 17 means that we have 19 neutrons. Right, so this is proton, neutron, and electron counting. In the next video, what we'll be going over is how to calculate the average atomic mass of a large sample of an atom, right? These right here refer to individual atoms of an element, or individual isotopic atoms or ionic atoms, right? What we're going to be working with in the next video is, what if you have a pile of atoms? How do you figure out its average mass?